Hi, everybody. We're going to do U5, which is find the number of solutions to a system of equations. I just did one with graphing, so I'm not sure what this one is. I haven't previewed it. So it's all going to be a surprise. U5, here we go. This is from Algebra 1, IXL, as usual. Okay, how many solutions does the system of equations below have? And they are completely different equations. So we know that because the two slopes are different, that they have to intersect at some point. That's the thing about lines. The y equals 2x plus 5 is a line that goes through 0, 5 and has a slope of 2 and so on. Because the slopes are different and they're not the same equation, then they have one solution. And that's it. It's that simple. This one have the exact same solution, so the same equation. So that means that there are infinitely many solutions. Now be careful. A lot of people think because x can be anything, that means that it's all solutions, which is not true. It's only the solutions that lie on the line 5x plus 2. Y equals 5x plus 2. For example, 6, 7 is a solution that makes this equation true. 6, 7. This is the only solution that you can use 6 for. So 6, 2, 6, 5, 6, 8, 6, 9, any other 6 with a different number besides 7 is not a solution. So it's not all solutions, but it is an infinite number of solutions, or infinitely many solutions of that form. So hopefully that's clear. This one have the same slope, but different intercepts. That means that they are separate equations. One of them goes through -6/7, which is pretty close to -1. And if you were to draw the lines, that one of them would go just about through -1, almost, and it has a slope of 1. So it's going to look something like this. The other equation goes through 8. 1, 2, 3, 4, 5, 6, 7, 8. But it has a slope of 1 as well. So the two lines are parallel. And they look something like that. They never intersect, so they have no solution. Whenever you have equal slopes with different intercepts, you're going to have no solution because they're going to be parallel lines. All right, same slope, same intercept. This is the same equation. So there is an infinite many solutions. This one has the same slope, that's 1, and different intercepts. So that means that it has no solution because they're parallel and they don't intersect. We're looking for the intersection as the solution. These are the same equations. So it has an infinite number of intersections because they're the same equation, 6 over 5x plus 7 over 2. Infinitely many solutions. This one has the same slope with different intercepts. So which one is it? They're parallel. They have no solution. Well, they have solutions. It's just that they don't have any solutions in common. Same equation. That means we have an infinitely many solutions. This one's going to go pretty quick, I suspect. This one may be a little harder to see. Notice that one of them has been changed a bit. Notice that if I multiply the first equation, if I multiply all the terms by 2, by the way, this is called a row operation when you're doing Gaussian elimination. Later on in this section, we're going to be solving equations like these. If I were to subtract these two equations from one another, I would get 0 equals 0. Kind of like when you were solving equations that were the same and you were doing identity equations. Anyway, they're on top of each other, infinitely many solutions. This one, there is no way to make them the same. And notice that I could go through the solutions, but if I were to solve this for y, if I were to solve this top equation for y, hopefully you can see how I got this. I am going to get +4 for x in front of the x. So the slope for the top equation is m equals positive 4. I'd subtract the 4x and divide by the -1, everything. The second equation has a slope, and this is really good practice. It's 15 over 11. Clearly, the two slopes are very different from one another, and that means that they are different equations, and there is one solution. Lots of other ways of doing it. And we could have solved for y and found it exactly. Now, be careful of these ones that end up having the same equation. Notice that if I multiply all the terms by 2 in the top equation, that the two equations are identical. That means that we have infinitely many solutions. Sometimes they say that these two equations are consistent but dependent. Dependent means that they're the same equation. Consistent means that they have solutions, and they have lots of them, infinitely many solutions. Little vocabulary there, sorry. This one we're going to multiply by 2, and multiply by 2. And sure enough, we get the exact same equation, don't we? Times 2, times 2, times 2. Do you remember? It's consistent but dependent. So infinitely many solutions. Lots of ways of thinking of it. It's actually not even really a system. It's actually just one equation. All right, this one. Notice that if we look at the coefficients of x's and y's, that there is no way to make equal fractions out of them. One way to think of it is that it's always going to be the x coefficient over the y coefficient and change the sign for the slopes. It means that they're different equations, so they have one solution. The slopes are different. You could graph both of these. You could try the intercepts and see that they aren't the same. Basically, if they're not the same equation, it's not this one. And if they don't have the same slope, it's not this one. The only thing left is one solution. And it doesn't matter if we can't find it. It's fairly complicated. Now in this one, let's take a look. 2 over 7 and 14, 7 over 2 and 6 over 14. It's actually negatives for the slopes, and they are different. So this is one solution again. Notice I'm looking at the coefficients of the x's and the y's. When I get to one where they give you the same slope, I'll point it out. Basically what I'm doing, and I'm going to go ahead and go through a little more in this one, plus 9y equals 2. In order to solve this for y, we're going to subtract x from both sides. I like to think of adding a negative x so that I can reverse these two. That gives me 9y is equal to negative x plus 2. I'm going to divide all the terms by 9. Now, I really don't care about this 2/9 over here. What I'm really interested in is that I get a negative 1 over 9x, and it is plus 2/9. But my main interest is with this slope, because if that slope is the same as the slope in the bottom, and they're not the same equation, clearly they're not the same equation. To get these to be equal to each other, I would have to multiply the top equation by 15. And clearly they're going to be different. So I know they're different equations. So it's either going to be this one or this one. Since they're different equations, it can't be infinitely many solutions. I found that one more time. I just looked at the first coefficient on the x. I multiplied the top by 15. And since the two equations are different, I know it has to be no solution or one solution. Those are the only two possibilities. Now, the reason that I found the slope is because if I look at the slopes and they're the same, then the two lines are going to be parallel. But because the slopes are going to be different, I know that it's going to be one solution. Now, the reason I know the slopes are different is if you look at these two numbers, the 15 and the negative 12, in order to solve this for y, I'm going to subtract the 15x and divide by negative 12 through all the terms. Like I said, the only important part is the 15 over 12, which reduces actually, excuse me, and 15 over 12 is the slope of this line. And you could go ahead and prove it if you want to go ahead and solve it. And that can be reduced. And a lot of people get scared because it's going to be 5 over 4. But notice it's nowhere near the same as this negative 1/9. So these are independent lines and they're consistent, which means they're not parallel. They have one solution. I know I went too far. We're almost done anyway, and it was a quick one. So hopefully you'll get it. Now in this one, in order to make these match up, I need to be really, really careful because notice that the top equation is written in a very different form from the bottom equation. And a good idea would be to add that 6x and add that 1 to both sides. I'm going to go ahead and do it on the side over here so you can see exactly what I'm talking about. I am going to add 6x to both sides. And I'm going to, and notice you can't add those together. I'm also going to add the 1. I really should have put the 6x further to the left, but there it is. I have 6x minus 4y. Notice the whole idea of this was to get a 0. And the idea of this was to get a 0. And it's going to be equal to 1. Now this equation is in the same form as this one, 12x minus 8y is equal to 2. And there's a reason I put them in the same format so that I can see if I multiply the top equation by 2, notice that they are identical. This is called a row operation. I multiplied the entire equation by 2. Some people like to say, well, I multiplied both sides by 2, but it's better to think of this as multiplying all the terms by 2. And we see that the two equations are exactly the same, which means that they are on top of one another, infinitely many solutions, however you want to think of it. Almost done. So now it looks like there's something going on here, and they're almost identical, aren't they? Negative 6x minus 8y is equal to negative 3, and I have negative 3x minus 4y is equal to 20. Now the thing is, if I multiply this bottom equation by 2, I want you to notice what's happening. Notice that the coefficient is the same. I get negative 6x, I get negative 8y, and I get different numbers over here. Now what that tells me is that the slopes are the same, but the intercepts are different. Remember what happens there. When the slopes are the same and the intercepts are different, then you're talking about the parallel lines. And they are independent. They're not on top of each other because these numbers end up being very different, didn't they? So that's going to be no solution. They're going to be parallel. All right, let's see what we got here. It looks like we need to use something called the symmetric property of equality. It says if A equals B, then B also equals A. So I'm going to turn that second one backwards. So we have 6x plus 4y minus 5 equals 0. And in the denominator, in the bottom equation says 18x plus 12y minus 15 equals 0. And look at that. If we multiply all the terms by 3, they are the same equation, aren't they? Remember what happens. Don't worry, that really is 0. And remember what that happens when you have the same equation, you have infinitely many solutions. And we're almost done. It wasn't too painful, hopefully. All right, we need to put it in the same format again. I could get them all equal to 0 in the numerator. That would be one way to do it. Let's do it that way. Let's get the numerator all on one side. So I have 7x minus 8y minus 1 equals 0. All I did was subtract the 1 from both sides and subtract the 8y from both sides. Hopefully you can see what I'm doing there. In the second equation, I'm going to go ahead and write it on the other side, alongside this one, 14x minus 12y plus 14 equals 0. Now, the thing that you want to be careful of is that it looks like this one, if I just multiply by 2, top equation by 2, it gives me the same thing, but notice that the y's give me a different answer. And of course, we call this the constant part of our equation, or the 0-degree term. Lots of ways to describe it. But our constant terms are different as well, which means that they are different equations with one solution. That will always happen when you have different slopes with different intercepts. You get one solution. And we're on our last one. Yay, we made it. So now I'm going to do the same thing again. I'm going to do this weird type of, they sometimes call this standard form, even though it isn't quite the same as normal standard form. 3y minus 3 equals 0. Notice I added the 3x to the front here, and then I subtracted the 3. In the second equation, I'm going to subtract the 10x, and I have a minus 10y, and I have a plus 8, and it's equal to 0. I just subtracted the 10x from both sides if you want to see what I was doing. Clearly, the x's and the y's are the same, have the same fraction. That's a way of thinking about it. If I were to solve this for y right here, I would get the same fraction as if I solved this one for y. Now, this one's a lot harder to see because there's no easy number to multiply to get them the same. But one of the tricks to row operations to see this relationship a little bit better, I'm going to multiply all the terms. In fact, I'm going to multiply the entire row by 10. And I'm going to multiply the entire row, you guessed it, by 3. This is like getting a common denominator. And you're going to want to do this later in this section, so you might as well learn it now. I end up with negative 30x plus 30y minus 30 equals 0. In the denominator, or in the bottom row, or the bottom equation, I get negative 30x minus 30y. I have a minus in there? Oh, they're very different, aren't they? Oh, this should have been a plus 3x. I'm sorry, guys. My bad. It should have been 3x. There it is. I don't know what I was thinking. Anyway, that's a positive 30x. Darn. And then to get them the same, I need to multiply by negative 3. I'm sorry, guys. I had a sign error there. Anyway, that's a positive 30x, a positive 30y, and a negative 24 equals 0. Now, the comparison is that this one is the same as these, which means that the slopes are the same. Because this number is different than this number, it means that they have different intercepts. Lots of ways of thinking about it, but the thing I want you to keep in mind is that I'm really looking at a parallel situation, aren't I? And to prove that, let me just divide everything by 3 in the top equation. This probably would have been the better way to go anyway. So divide everything by 3 in this top equation, and I get negative 1x plus 1. Now in the bottom equation, if I solve it for y, I'm going to end up subtracting 8 from both sides, and I'm going to have negative 10y equals 10x minus 8. I'm subtracting 8 from both sides, and then I'm going to divide everything by negative 10. Sorry, it's a little, I'm running out of space, but I just wanted to show you what I mean. Now look, I have y equals, this is negative 1x, just like this one is negative 1x. And this one is 1, and this one is 8 over 10. They're really close to one another. In fact, if I were to graph these on a graphing calculator, you probably would think that one is on top of the other because they're going to be so close to one another. And that's why they did what they did. Anyway, these have no solution because they are different lines, but they are parallel. So there it is, the last one. Hope you'll try it yourself and get your mastery, and I'll see you back again. Bye-bye.